Welcome back. Today we're going to continue with the quadratic functions. In the last video, we saw how to transform the parent function y equals to x squared. Now, we're going to see how to shift our parabola. We'll see how to move my parabola up and how to move our parabola down. We are going to learn how to move the parabola left or right. And finally, we're going to do both shifts at the same time. Now we remember the vertex form. H is going to tell me how many units the parabola is going to move to the left or to the right, and K is going to tell me if my parabola goes up or down. For example, if we want to know the graph of x minus 3 squared plus 2, well, we need to be careful here because of this negative sign. If the 3 is negative, we're going to move to the right. But if the 3 is positive, we're going to move to the left. Okay? And this is positive 2. That means if it's positive 2, we're going up, and if it's negative 2, we're going down. How is going to be this graph? Let's use GeoGebra to find the solution of this graph. Let's start with the vertex form. Y equals to x minus h squared plus k, where h is going to tell me if my vertex or my parabola is going to move to the left or to the right, and the value of k is going to tell me if my parabola moves up or down. Let's say we want to graph this, but let's do it in two steps or two different functions. First, what happens if we have just the first part? What does it mean? I have a shift where, remember, always what is inside the parentheses is going to tell me if I am moving left or right. Now, if this number is negative, I am moving to the right. If this number is positive, I am moving to the left. Let's use GeoGebra to know how it's going to be the parent function in this shift. Okay, we're going to graph our parent function. It's x squared, and we're going to graph our shift, which is x minus 3 squared. As you can see, our graph has been moved 3 units to the right. What does it mean? My vertex, which is in 0, 0, is moved 1, 2, 3 units. This point here is going to move 3 units to get to this point. And this point here is going to be 3 units to get to this point. It's easier to see it in, for example, this is 1, 1. Then if I move this 1, 1, 3 units to the right, it's going to be 1, 2, 3. And this one is negative 1, then 1 unit, 2 units, and 3 units. As you can see, each point of this parabola has been moving 3 units to the right. Right now, we just moved our graph to the right 3 units because we have a negative 3, we're going to move 3 units to the right. But what happened with this positive 2? If I want to do now my original function, well, I already moved the graph 3 units to the right. And what I need to do now, because it's positive 2, I need to move all my points 2 units up. We're back in GeoGebra, and now we're going to move. We have x minus 3. We're going to move our graph to the right 3 units, and we're going to move that graph 2 units up. Look, my vertex is in 3 for x, 0 for y, and now my vertex has been moving 1, 2 units up. And all the points have been moving 2 units up. Then, if I just want to know what is the relationship between the parent function f of x equals to x squared and my final graph, the only thing that I need to do, I'm going to turn off the x shift, and now we know, for example, the vertex is here in 0, 0 for my parent function, and my final vertex is going to be where? 3 units to the right and 2 units up. Let's see. 1, 2, 3, and 1, 2 up. Now I know my vertex, and it's going to be true for all the points. Now, let's do it for this point. This point is 1, 1. 1 for x and 1 for y. Now I need to move 3 units to the right and 2 units up. Let's do it. 1, 2, 3, 1, 2 up. I am here. You see, it's going to be true for all the points. Now we're going to do another type of shift. What happens if I just have my parent function and I want to move it, my parent function, up or down? What I need to do? Well, the only thing that I need to do is to write my parent function, but if I want my parent function goes up, I just going to add any number. Let's say in this case 2. That means all my parent function has been moving up. How many units? Well, the number of units I have here in this case is 2. And it's going to be the same if I want to move my parent function down. Let's say I have just 1 unit down. I'm going to erase this, and I have my parent function has been moving 1 unit down. Now let's do a final practice. If I have the graph, how can I know what is going to be the formula or the equation? This is 0, 0, and this is going to be 1, 1, 1, 1. That means this is going to be my parent function. Y equals to x squared. Now, what happened with this one? If you see, my graph is 5 units to the right, and I don't have any shift movement up or down. That means my graph is going to be x. Remember, if it's negative, it means I'm moving to the right. X minus 5 squared. In this case, what happened? Okay, where is my vertex? My vertex is in 5, negative 4. Negative 4 for x, positive 5 for y. Well, how is going to be my shift? Y is going to be equals to, but look here, the difference is this is opening downward. How can we do that? Well, the only thing that we need to do is write a negative sign, x, and now I have the same. How many units? To the right I move 1, 2, 3, 4. Because it's negative, here is going to be positive to the second power. Now how many units up? You can see I move 1, 2, 3, 4, 5 units up. That means it's going to be plus 5. Don't forget to be with us in this series. We're going to continue with the quadratic functions now in the standard form. See you!